Okay, welcome back. Here is 5.4. This portion of the video from 5.4 is going to cover homework problems number 6 and 8. So let's take a look. Number 6 says a rectangle has its base on the x-axis and its upper two vertices on the parabola y equals 12 minus x squared. Upside down parabola. We'll get to see it in just a second. What is the largest area the rectangle can have and what are its dimensions? So I've gone ahead and drawn that. Again, I'm just going to read back through what it said here. A rectangle has its base on the x-axis. Now, that's just arbitrary how wide I made the rectangle here. And its upper two vertices on the parabola, y equals 12 minus x squared. What is the largest area the rectangle can have? Okay, so at this vertex here, this would be the point x, and whatever I put in for x, I get 12 minus that, so this would be 12 minus x squared. This distance would be x, this distance would be x, and therefore our area in terms of just x would be 2x times 12 minus x squared. And so let's take a look at this guy. We can find some reasonable values for x, but area in terms of x is negative, that's terrible, negative 2x cubed plus 24x. And if I want to know what the graph of that area function would be, not too bad. I've got a 0 at 0. That makes sense. If I choose 0 for x, then we'd be 0. And if I set 12 minus x squared equal to 0, that gives me square root of 12. That is 2 root 3, which basically is back out here where it'd have 0. So at 2 root 3, we'd look like this. And that's a double 0. So excuse me, that's plus or minus 2 root 3. So this function wants to look like this negative cubic, has another 0 over here, wants to look something like that. We would only be interested in x values from 0 to 2 root 3. Okay, so we're going to find this leveling off point, expect to find two of those. Let's find our derivative. A prime of x is negative 6x squared plus 24. We set that equal to 0. And we get x squared equals subtract 24 divide negative 6. And we get positive 4. And we get x wants to be plus or minus 2. So our x value for this problem is just 2. At 2, we've got our greatest area. Back to the question. The question says, what is the largest area of the rectangle and what are its dimensions? So back to our area function. Area based on 2 is 2 times 2 times 12 minus 2 squared, or 4 times 12 minus 4, 6. Oh, excuse me, 12 minus 4, 8, or 32 square units. And what are the dimensions? The dimensions are the rectangle would be 2x4 by, put 2 in for our y value, 4 by 8. So there you have it. Not too bad. Maybe coming up with the diagram causes maybe a tiny bit of trouble, but I think we're in good shape. Turn down my brightness just a little bit here. And let's take a look at number 8. Closing off the first quadrant, classic problem here. You're planning to make an open rectangle, you're planning to close off a corner of the first quadrant with a line segment 20 units long running from A0 to 0B. Show that the area of the triangle enclosed by the segment is largest when A equals B. This is not so different than number 2. So number 8, we're trying to show that if this length A is the same as this length B, that will give us the biggest volume here, the biggest area, excuse me. So what do we know about A and B? This distance would be A, this distance would be B. I've got a Pythagorean relationship that says a squared plus b squared equals 20 squared, or 400. I also am interested in the area. Right now, the area based on a and b would be 1/2 a as our base times b as our height. But I don't want area of two functions. I want area, or of two variables. I want area of one variable. So this would be a equals 400 minus b squared plus or minus square root of, but we only want the positive value here. So a can be replaced by that. So area based solely on b would be 1/2 times 400 minus b squared to the 1/2 power, that's our square root, times b. First derivative, of course, area with derivative of area with respect to its base, or excuse me, with respect to its height, b in this case. Product rule, derivative of first is a mess, 1/4 times 400 minus b squared to the negative 1/2 times the inside derivative, negative 2b, times the just plain second b, plus the just plain first, 1/2 times 400 minus b squared to the 1/2 times the derivative of the second, which is 1. And we end up with negative 2b squared on 4, or negative b squared on 2, with a 400 minus b squared to the positive 1/2 in the denominator. And we end up with plus 1 on, not just 1, I'm going to need more than that, all on 2. Let's see, I'm going to do this. 400 minus b squared to the 1/2, all on 2. Let's get common denominators. I need a factor of 2. I need a factor of 400 minus b squared to the 1/2. Good news, negative b squared was on that. More good news, when I take this to get common denominators times this factor, that's the same as this, so I just get plus 400 minus another b squared, all on our least common denominator. So a prime b, the big payoff, I get 400 minus b squared, all on, I'm going to call it star. Okay. Because a has to be less than 20, we don't have to worry about non-differentiables. A can't be 20 and still create a triangle. Therefore, we're just interested in when our first derivative is equal to 0. That's when b squared, oops, that's 2b squared, excuse me, minus 2b squared. That's when minus 2b squared plus 400 equals 0. That is when b squared, what do I have here? Minus 2b squared, sorry, I don't think I'm going to redo this video, so you got to work with me here. Minus 2b squared plus 400, that would be when b squared equals 200, or when b equals square root of 200, or 10 root 2. It'll be plus or minus, but that's going to be positive. But this is 10 root 2, and by Pythagorean, quickly we see 10 root 2 to root 20. This is in a ratio of a 45-45. So, question says, for number 8, show that the area of the triangle enclosed by the segment is largest when a equals b. Therefore, the largest triangle is when a equals 10 root 2, b equals 10 root 2, or when a equals b. All right, sorry about a little sloppiness there, but we've got problems through 8 complete, and stay tuned. We'll be following that up with a couple more.